Yes, I'm Dr. Kathy Sawyer. I'm here to see Sam Bailey.
Let me see if I can find him for you. Hello, I need Sam Bailey in the front office, please. Well, here he is now.
Hi, Doc. Nice for you to come.
I'm glad I could be here. You know I'll be called on regularly to judge whether workers at this facility can return to work after an accident or illness, so it's important that I know what goes on here. I'm looking forward to discussing ways in which the environment's been improved for the workers by reducing the amount of dust that they're exposed to.
Well, what I'd like to do is play you a videotape which shows the potentials for dust in our plant and mine. Then I'd like to give you a walking tour so that you can get an appreciation for what we do to control dust. And I'd like to start with where we mine the material, how we transport it, and how we prepare it to be processed.
Okay, let's go.
You see that truck over there? Sometimes even loading a truck can be a potential dust problem. So what we've done is we've told everyone here to keep their windows closed and their ventilation systems running in order to avoid exposure. Sometimes on dry, windy days, the roads dry out completely. So what we've done is we've treated the roads with a calcium chloride solution, which keeps the dust under control. What we do not do is run trucks on very dry roads without applying the necessary water to suppress dust.
I see what you mean, Sam, and I'm glad to know that your equipment operators know to keep their windows up.
As we begin to reduce the size of the rock, we use more and more energy, and as a result create more and more dust-sized particles. You can see how we're dealing with this issue by using a water spray.
Well, it sure looks like the water spray works well.
Yes, it would be quite messy without the spray. Well, now let's go back to the plant and I'll show you a videotape of some potential dust hazards and what controls we use to eliminate them.
Sounds good.
I see here in the video that the rock that we'd seen in the crusher earlier is now a very fine material that's going to switch from one conveyor belt to another.
Yes, Kathy, you hit the nail right on the head. Here we're going to see one of the more potentially dusty places in our plant.
Well, I don't see any dust, though. How do you do that?
Here we begin to enclose the area of a potential dust problem. You can see the dust collection and transport systems we use to minimize potential hazards. If this place weren't properly engineered, we would have major problems. We never operate with major leaks. Instead, we stop the process and fix them right away. Another practice we've adopted in this area is washing dust away rather than sweeping it up, since there would be a lot of fine dust created by sweeping. At these capture points, we've been able to capture a lot of the dust before it escapes into the plant air. But our job becomes more challenging as we move into the drying section.
I see what you mean. It looks to me as though you're intentionally agitating the material inside the dryer to get it dry.
Yeah, that's right. This process creates a very dusty environment.
It doesn't seem very dusty in there. How do you keep this area so dust-free?
Well, if you'll look closely, you'll see that there aren't many large openings where dust could escape from the dryer. You can see the special ducting that we have to take the large volumes of air necessary to burn the fuel we use and to carry the dust away from this area. You can also see the special type of ducting we have used that allows the large particles to fall back into the dryer while conveying the fine dust particles to our dry dust collector.
Yes, and I understand that there are other techniques like scrubbing that can be used to do the same job that the dry dust collector does, which would reduce the exposure to workers even more.
Yes, we have a wet scrubber in another part of the plant which does essentially the same job as our dry dust collector does on our dryer. We go from the frying pan into the fire of the screening plant, if you'll pardon my expression.
You're forgiven, Sam.
Here in the screen house, the process breaks up any agglomerated fine material and separates it from the coarse material as it passes through and over the screen beds.
It's as though you have a large number of screens as well, so that means you're trying to get every grain of sand abraded as much as possible.
Yes, there is a lot of mechanical activity in here, and we deal with this issue of dust escape here by moving large volumes of air through the screen areas and through the ductwork connected to our screenhouse bag collector. If those collectors weren't working, this place would be one massive cloud of dust, and everything in here would be covered with a fine film of material we're trying to avoid.
I'll bet that you have a problem in there with all those moving parts and that very abrasive silica sand going through the system? And don't you have to clean those screens every now and then?
Yes, we do. It's a very high-maintenance area, and an area that is very important to our success in keeping a dust-free environment. We also pay careful attention to the dust exposure of the person cleaning the screen. Notice how he's working with the covers closed and his respirator in place. No one is allowed to work in this area without proper equipment. And screening is an area where we've had good maintenance over the years, as we realize that maintaining this part of the plant will mean success in our dust control efforts. Falling behind in our maintenance or sloppy habits would be a surefire way for us to have ever-mounting problems.
With all this potential for dust exposure, how do you ensure that your dirty clothing doesn't hide dust until you take it home and shake it out or clean it?
The old-timers used to solve this problem in an obvious way that is now forbidden in our plant. They simply glue it off. This approach is not allowed, so we provide special vacuum cleaners to our employees who get dust on their clothing so they can remove the problem before they go home. In some cases, we provide disposable coveralls to help protect the employees' clothing. You know, we don't sell all of our material in trucks and rail cars. We put some into these paper bags.
Oh yes, I've seen them in stores. They're used for all kinds of things like masonry sand or sandbox sand or grouting sand.
Here's an area that we've concentrated on over the years, and through better engineering we've had a lot of success. As you can see, we must take the material from a bin and put it into a paper sack, and get that sack closed before the material can escape into the area around the person doing the bagging. It's a real challenge.
Oh, I see what you mean. In spite of the special bags, there still seems to be a little spillage before the bag is sealed and placed on the conveyor belt.
Yes, that's right. So as a result, we have a very high level of dust control in this area and make every effort to operate with machines that do not expel lots of dust at the end of their fill cycle.
Where do the bags go from here?
Well, we load them into trucks or rail cars, and occasionally a forklift catches a pallet and rips the bags. When this happens, we stop the operation and with vacuum cleaners clean up the spill. We never sweep the material. As you can see here, the confined space of a trailer is poorly ventilated.
It would be pretty tough to move the air out of the tractor trailer, since the door in is the same as the door out.
Yes, and we have a similar problem when we are loading bulk railroad cars and trucks. These vehicles are large volume equipment and require us to put our material in at a high rate of speed, which tends to agitate the product.
I'm catching on now. I can see you've installed special spouts to allow you to collect the dust as it passes from the bin into the truck.
Absolutely. But when the equipment goes down, it can be extremely dusty. So when that happens, we do not operate. Kathy, this is our silica grinding and sizing area, where we produce products that are an even smaller size.
So engineering controls are more important than ever in this part of the plant.
They're an integral part of a well-designed, operated, and maintained plant.
I see here that you've used the same system as you do in other parts of the plant to control dust.
Yes, it's very important in this part of the plant not to have ducts with holes, spills, or poorly designed equipment. It's equally important not to have bad work habits such as dry sweeping floors or cleaning up with compressed air.
Boy, it sure could be dusty in your operation. I'm glad to see that you have the equipment in place to control dust.
Well, now that you've seen the videotape of our plant, I would like to give you a tour so you can get a better understanding of how our dust control efforts really work. Doc, I'd like you to meet our safety supervisor, Earl.
Nice to meet you, Earl.
Nice to meet you.
Earl has a very important job of helping us work safe in a dust-free environment. He works with our plant manager and with us to help keep our plant clean and safe.
Welcome to our plant. Why don't you come in and have a seat?
Well, thank you. You know, Sam, your plant manager gave me a copy of the National Industrial Sand Association publication, Implementation of Dust Control, New or Existing Facility, published in 1994.
Yes, that's the same type of program that we have here in our plant.
As you may know, proper dust collection equipment maintenance as well as process equipment maintenance is imperative in dust-free work environments. And we have a state-of-the-art system that monitors all of our dust collection equipment so we can provide a dust-free and safe workplace. Even though we try to design our plants to be optimal, they rarely are because of unique problems. But our dust collection monitoring system keeps track of all of the point sources out in the plant.
Well, yes, you do have more than one kind of dust control. Sam showed me both a baghouse and a wet scrubber.
Right, and each one of these devices needs to be controlled a little bit differently. Baghouses have an engineered pressure drop, and wet scrubbers can be monitored by either manometers or U-tubes.
Well, I suppose the point is that if the plant is going to dust collect material, the dust collection equipment needs to be working all the time. It's not good enough to have it installed if it is not working properly. Is there a system in place where the workers can know if the dust collecting is working?
Yes, of course. If the equipment isn't making any noise, well, then it probably isn't running. But seriously, though, we also have real measures from gauges and meters so we can be sure that the water flow and power draw and pressure differentials are corrected for each piece of equipment. We can also tell by using a special device whether we're emitting material into the environment. We can tell, for example, by reading this amp meter whether or not the pump motor is working that feeds water to the spray bars in the wet scrubber.
I see. So you have developed simple ways that plant workers are able to tell if the equipment's working correctly.
Yes, and I've been trained to know what they mean and what to do if I see an abnormal reading. Remember, we can't always see respirable dust in the size range that can do us the most harm, so we have to be sure in some concrete way that our dust collection system is working.
Understand also that the National Industrial Sand Association has a volunteer assistance program, and if we have a particularly difficult problem, we can call in engineers from other companies.
Yes, and we can also call on the Mine Safety and Health Administration for technical support services as well. The National Industrial Sand Association and the Mine Safety and Health Administration are reliable sources of engineering and maintenance controls for industrial sand facilities, and we use them whenever we can before a problem starts.
Well, I see that you know how to determine if your equipment is working correctly or not. But is there some kind of a system where you can track the results of your readings over time so that you can tell the changes in your environment before it becomes a problem?
Yes, we do, and if you'll follow me, I'll show you where we keep our records to track the plant environment. These are readings from our dust collection performance system where we evaluate the manometers and U-tube gauges, and then we track this data and graph it so we can predict any potential problem areas.
Yes, I can see that you're using charting to show what's going on, but it's very clear to me that it's important that the information you collect be reliable and regular. I'm sure there must be times when your job calls you to do something else and you just as soon not write down the readings in the logbook.
It's tempting, Kathy, but we keep a rule at this plant to track these areas and invite our engineers and technicians to help us analyze the data and fix the problem. We analyze the data, and as trends build, we take aggressive action to find the problem and fix it.
I can see that the input of all the workers is extremely crucial, and I think that you've done a good job here to pinpoint potential problems and to take quick action before a trend takes place. But how do you get management to take action as quickly as you need them to?
Well, we use charting to show our supervisors where the problems are. And if there is a problem and a response is delayed, we attempt to avoid the area. But if we can't, we put on the proper safety equipment, including our respirators, before we go into the problem area. The management has given us authorization to shut the plant down if a spill gets out of control.
Well, Sam, your plant is a very clean place to work, and I'm impressed with the rules and regulations that you have in place to make sure that it remains that way. I hope that all your employees realize that dust control is everyone's responsibility.
Kathy, even though our plant is clean, we understand that silica dust can be hazardous, and it's our goal to control the dust in the workplace and keep it out of our lungs. And we do this by using design dust control methods to draw the dust away from the worker, by monitoring the dust concentrations in the workplace, by acting promptly to find and eliminate the sources of dust if a problem is found, by monitoring our dust control equipment with flow meters and pressure gauges that tell us that the equipment functions properly, by maintaining our dust control equipment, by keeping records and spotting potential problems before they occur, by involving all of our employees to spot, react, fix, and prevent potential dust problems.
Does your company do anything else?
Yes, we have an entire silicosis prevention program, which includes medical assessment of the employees, dust control and ventilation, monitoring dust exposures, respiratory protection and fit testing, employee involvement, and smoking cessation programs.